And I would say we can start with this super boring topic at the end of the day, so I'm pretty sure everybody will fall asleep. With the topic of writing tests that spark flow, tests that are efficient to use, tests that are fun, maybe, hopefully, and how to make them a little bit more, well, effective. My name is Sebastian, born and raised in Munich, Germany, and I work for this company called IBM, and I do a lot of things on Java and a lot of things on enterprise. In general, that's my background and a lot of Java titles involved here. And another fun fact, I like coffee. So I'm very, very happy to be here and to be back. I was visiting your Java user group here in Lviv once, and you get good coffee everywhere. Actually, you have to stop yourself to not drink too many per day. That's what I noticed. But yeah, it's very, very nice. And especially since I like coffee, we will have a coffee shop example application. So that's what we're going to do. We're going to talk about this testing perspective from a very pragmatic and practical point of view. I will show you a lot of live demos and live coding. And also what is very important to me, that I show you an example that is at least complex enough that we see all of these points that are interesting in real world projects, right? Because I see a lot of, conference talk driven development where you say, oh, use this and that framework or this technology or this approach that scales not that well, that works very well on, hello world like examples. But once you get a little bit more complex, then you get other constraints that you have to take into consideration. So what we have a coffee shop application that the user can use via some endpoint, right? So you can order a coffee, and then at least we already have some database, so some persistence involved that you would need to verify. And also what we have a barista, which is a second external system. We treat that as an external system that's not developed by us, but doesn't matter. And to make it a little bit more interesting, that's an asynchronous communication in between. So there's not a synchronous, but an async approach right there. And that's pretty much it. So what I can show you is the coffee shop example application that's now a Maven build and the POM here. I use Java with Quarkus. So you can, I'll explain a little bit about that. And that's just a Java project. And just because I'm brave, I use JDK 13. Who of you uses Java 13 in production? Yay, that's what I expected. Who uses Java 9, 10, 11, or 12? Okay, that's good. And the rest, I guess, Java 8? Yeah, well, that works already. So we will have this application here, and then basically what I can show you is just to, build and run this, is I will just deploy this locally using Docker containers. So you will see from a technology perspective, I will use a lot of containers here. And then I can show you the running example already that basically, where I build up these three components locally, just to see, for you how that works. That this is the main important application, the coffee shop, and we will have also other components there. And then we can show this already. So what we're going to have is we have three containers. Show this by Docker PS. One is called Coffee Shop, Barista, and Coffee Shop DB. And that's basically what we're going to use. And let's just see on the command line how we would use this application. So what we can do, curl localhost, that's the port that we're going to have. We have a look at the application here, and this shows us, okay, some hypermedia-like response where we can have some, coffee types and coffee orders. It shows us the action how to order a coffee. So basically, if we go to /orders, we see the coffee orders in JSON, and that's empty. So there are no orders in the system. We could also have a brief look. I don't want to go too much into that at the resource. So this is Quarkus code /JakartaE, so JaxRS. You might have heard of that. If you come from a Spring background, that is very much like a Spring REST controller. Looks very similar with its declarative annotations here. And it's basically maps /orders to create and read and so on the coffee orders. And then we have things like, JSON array, give us the orders. Please order a coffee. So this is quite interesting to see, okay, we gonna build an order here, and the order then ultimately will be persisted to a database. And it has, well, what is a coffee order? It has a drink type. That's an enum, you know, like you can order an espresso or a latte or something like that. And also an origin. So you probably have seen this outside at the better coffee places. You sometimes can select an origin, right? If you want beans that are coming from Ethiopia, Kenya, Colombia, you know, whatever you prefer, depends on the taste. So we're gonna include that as well. And then basically what we're gonna do, let's order some coffee. So in this case, we will post something to this resource. You've just seen that in the code. So we're gonna post some JSON here that is, well, what do you like to have? Let's say espresso, okay? And coffee origin, that's also what is required. Let's say we want some Colombia coffee. That's what I enjoy. Okay, 201 created, that's good news. And then we're gonna have the response here. Type espresso, Colombia, status collected, okay, because I was a little bit too slow. Because what we can see, that we have a status update, and that is basically the communication between coffee shop and barista here. Asynchronously, it's gonna poll for the update because the friendly barista person is gonna brew our coffee, right? So let's do this again. If I post some coffee once again, then at first we will see that it's preparing, and then at some point it will be finished quite quickly afterwards, and then at some point it will be collected. So these are the status transitions that we have, just as an example. All right, so works, right? I just tested it, so ready for production. So what I just did is a manual black box test, if you want. So I tested the application from the same perspective like a user, like a client would, by using the outside endpoints without knowing too much what is going on inside. And this works fairly well. It would be a similar use case what a client does, but the problem is that is, of course, just once, you know, tested it once without any regression in mind. So it works now, and that's quite a decent way to test it, but then 2 weeks from now, if I change some other functionality, who knows whether that's still valid, right? So we need to automate something. And in this case, I want to start with that scope, basically with a black box-like system test approach, where we have a running application that runs ideally very similar in a way how it would run in production, with containers that is quite easy to achieve locally. I run a Docker here just very plain locally. You could also do Docker Compose. You can even run a Kubernetes cluster locally. It would be a very similar outcome. But then, well, we're gonna see whether that works. So in this case, I did it manually. We could use bash scripts if you want with the same curl commands that I just typed in, or, and this is the point because it really doesn't matter, we use Java because we're just used to Java here, right? And what we could do in this case, and I have a few different testing scopes or projects that I can show you. Let's start with something that I call create order naive test. Why naive? Well, that's a quite naive approach how I typically see that in projects, how you would test what I just did from a Java code perspective, right? So if you have a look at this, that is now JUnit 5 Java code that uses a JAX REST client, that's the HTTP client component. Really doesn't matter, you could use whatever you like. And that does a quite naive approach of saying, okay, we're trying to build up some URL, we're trying to connect to a local host, and so on and so forth. And then, okay, now it's getting interesting. And that is already the first point I want to make. Let's create some coffee order here. So what we do, well, we at first need to, post some JSON to that resource, right? That's what you've seen on the command line, so I can do this in code as well. Looks a little bit like this, order, espresso Colombia, okay, fine. Then target, this looks like this, post some JSON here, and then of course check whether it's successful, yeah, fine. Then you saw probably the location in the HTTP location header, which we would need afterwards. So we're gonna store that and then check whether this order is in the system correctly, right? It's the same thing what I did here with just querying for the order, or I can also query it directly to see whether that looks right. Yeah, all the information is correct, right? Because we want to see whether the persistence, for example, works correctly, part of that test. So we're going to load that again using this URL and then assert that, all of that information is correct. And then we can even go to the target where all of the orders are included and see whether our order is included there as well. Okay, who thinks that's a good idea? Who has seen tests like this? Probably. So what is the problem with that? First of all, not that much. It's kind of like the same what I did. But what is it what we actually going to test? Well, we want to create a coffee order, right, with espresso from Colombia and things like that, and then we want to see whether that's stored correctly. So what happens if tomorrow I'm going to implement not only espresso, but let's say cappuccino from Colombia? Well, you know what happens because you've been in these projects. So we're gonna, of course, doesn't even fit on the screen, copy, paste everything here, right? And then say, okay, create verify order with cappuccino as well. Change this to cappuccino. And then we're gonna have a look at, because, well, where is it? Yeah, looks pretty good, right? That's a decent approach. You've probably seen an approach like that. And then, of course, what happens if 2 weeks from then, we not only have Colombia, but Ethiopia, another country, another origin. Okay, great. So now we're gonna, copy paste again and then say, oh, create, verify order, espresso from Ethiopia, cappuccino from Ethiopia, espresso from Colombia, and so on and so forth, and nothing is maintainable. So what is the problem with this test that I just created in this naive approach? Well, it has too many concerns. It's basically it does too much, or in other ways, it has too many concerns here because it mixes up multiple things. It mixes up the test scenario, what I want to test, with, well, how I'm going to test it with the implementation. So what I want to do instead, and create order naive test, let's copy paste this, test 2. And what I would like to test here, create verify order, and I'm just going to delete everything. It's always a good idea. What I would like to test, and I now do this in pseudocode or in comments, and no kidding, I do the same actually in projects or sometimes even on paper. If I want to come up with a better test scenario, how should we start there? Well, start from that perspective, actually what you want to test. What is your test scenario? So what do I want to test? I want to test to create a coffee order, right? Create coffee order. If I could type, yeah, it's late. With espresso, and let's say from Colombia, right? Something like this. And then something like verify order is in the system. Or, do something like order ID and then save order ID and then verify that order ID basically is an espresso from Colombia. Something like this. That's it. That is the abstraction level that we want to talk about, not more. I don't care about HTTP, I don't care about JSON, I don't care about all of the details that make this totally unreadable. I cannot even see what I want to test, Espresso Colombia, because it's just cluttered with all of this code that talks about status codes, about location, HTTP headers, JSON. I don't care. The question is, what do I want to test? What is my test scenario? And that is basically right here. Or in other words, I implemented this a little bit cleaner here. Create order test. Create verify order. That's the same thing I did before. Now have a look at this method. Order. It's new order, Espresso Colombia. Okay. Coffee order system, whatever that is, create order. Okay. How does it create my order? I have no clue. Coffee order system, get the order. You just got some information, some identifier, some URI, whatever, and now try to load that order and now assert whether the information matches. That is what I just wrote with verify. And bonus points if you also check the all orders and see whether it's included in that list, the identifier. That's my test scenario. That's what I want to test. And now let's have a look at this delegate. And that is super simple, plain JUnit. I'm not having any magic. It's just instantiating a class. What is this? Well, of course, that is the facade. Here, how it's going to test it. So what do I do if I say get orders? Well, of course, I need to go to this URL and then JSON and HTTP and all these things. Yes, that's what we just did. Or create order. How do I create this order? Well, I need to send the request. Then this also can do some verification logic here. Verify whether that's, if it's invalid, an error, or whether it's successful, and so on and so forth. So the point is, I'm creating abstraction layers and I'm delegating here. And of course, I'm telling nothing new. You always do this in a production code, right? there we care about proper code quality, but usually with test code, nobody cares, right? So the result of this is that the test here becomes much more readable and of course much more maintainable. So if I'm gonna create another method where I change, well, espresso to cappuccino, then the difference here is this is actually readable. It just says in these, what's that, 7 lines of code, what I'm gonna test. This is actually the description of my test scenario. And then I can, copy paste it if I want. The point is, I'm not screwed if anything changes in the implementation here, right? Because typically if I have the naive test and then it says, well, what happens if here HTTP changes for something else or JSON changes for something else? Well, yeah, then you can throw away your test, right? Because you would need to modify all of these 200 test methods that you just happily copy pasted. So again, it's nothing new. The most important thing here is abstraction. Abstraction, that principle, and I use delegation in my tests, and again, that is nothing that is forbidden to include proper test code quality. It's actually a good idea, and it makes my tests, of course, much more readable. So that is just one aspect here of how I make these system tests a little bit more maintainable, because they can include quite a lot of logic. This is just a very simple way of doing some HTTP magic. But now let's get a little bit more complex with testing what I just showed you with this different status transitions. So testing whether all of the integration works correctly. So testing the contracts that my application had, I implicitly tested it by just accessing it from the outside, and also what the barista system does here, right? So you saw I was starting some barista system, which was just my running, application that might be implemented by a different team. But now what I want to do, I want to create a system test or system black box test that basically focus on my coffee shop application, and everything else similar to a unit level test is mocked away, right? Because I don't care. I assume that the barista system works as expected, but then I can mock it. And by doing so, I can verify whether this communication works correctly. And this is what I do in this test here, create order test. So now what I'm going to do, I just had these Docker containers here. Let's going to stop them again, because I'm now setting up a different environment, a system test environment that starts the same things, except my barista is now a mock. And I use WireMock as a mocking technology. That's basically an HTTP server that I can control from the outside, very similar to what Mockito does on the Java code level. And then what I do, well, I'm gonna having more updates here. So this is now the little bit more complex method, create order and check the status update. So what it does, I create an order, and then, what I just did before, and then I want to make sure that actually this communication works as expected. We know that this is asynchronous. It makes it a little bit more tricky. So we just have to make sure that at some point, this barista backend will be invoked correctly. And then, of course, in our scenario, we want the barista mock to play along. So we say, hey, by the way, if you get the response, please respond in the following way, so that the transition update works as expected. And this is what we're going to do here. And now you see that also I have a delegate for the barista system, and only now it's actually readable. I mean, imagine if I would inline all of this, then you're lost. But basically what we say, barista system, please answer for the following order. And what it does, well, it includes WireMock, and we assume that now under this other name, barista, there is WireMock running. And then we can say, well, answer for the order means, please, dear WireMock, stop for the following post request in this case, and then answer accordingly. So that is basically what we're doing. And then we can see again whether the information is correct and things like this. And then what we have to do, well, basically we have to wait. Why? Because that is an asynchronous invocation, and we cannot make sure that immediately the status update will be there, right? So we can poll the other system, and there is no better way to do that, to wait for that invocation to happen. So we just want to make sure that at some point that request will be matched for our given order, and then that the status transition was called with the correct status. All right, so this is now started. let's create this test now so that actually you see that this works. First of all, I'm gonna do the create verify order test that is now on a Java level, the same thing that I did on a command line, and you see this runs very quickly. Why? Well, it connects against a system that is already running. I'm gonna talk about life cycles a little bit in a second, but let's start the second test. That is a little bit more interesting, and that does the status transition. So now you see it runs slowly, but that is not the fault of the test. That is part of the business logic, because actually this asynchronous process, it's an internal polling, and that takes a few seconds to do this ping pong until all of these statuses are there. And then you see, okay, this now works as well. The way how we write our tests, they are idempotent, so I can just run them again, because these UUIDs will be generated newly, they don't collide. And first one already succeeded, the second one as well. And we can actually go and see that this was not order, but orders, that this was created here. So we have some new requests coming in. All right. Now, that is already one way how to verify these system tests in a black box way that run locally. Now, for me, what is very important to tell you here, and for me that's an important fact for testing in general, is how to make this as efficient as possible for us. Why? I named this talk Test That Spark Flow, and that flow experience I think is very, very important for us developers, because developing coding is a flow experience, right? You code something, you think about a solution, and ideally you want immediate feedback, right? So you write something and then you test it. I'm going to show you unit and code level tests in a second as well. There it's easier, but typically what we do, well, we write some tests or we write some code, and then we need to start up our application, right? Because in order to verify all of these things, typically we need to start that up. But that takes time. Technology gets better and better. If you use Spring Boot, that starts up in a few seconds. Quarkus actually starts up even faster. But still, if you use like 5 seconds or longer for the startup time, we're humans, we get distracted. So there's some science behind that everything less than 200 milliseconds feels instant. Gmail originally had that mantra that every action has to be less than 200 milliseconds. So that would be ideal, because then it's just right there. So you do something, you fire the test, and it's right there. Everything up to 2-3 seconds is basically where your brain is in this active blocking mode. So you start the action, and then you're like, okay, now it's done. And everything more than that, well, we're humans. It depends on your attention span, but at some point you use this nasty device, horrible for being productive, and then it's like, oh, there's an update on Slack, and what's the latest, Twitter and email, and then you're gone. Then you're out of your flow. So ideally, we're forcing our workflow to stay below that. How do we do that? Ideally, in my eyes, to separate life cycles from the test and the test environment. This is very fast, what I showed you, because it's starting up the environment once. I was using bash scripts. You can use, Docker Compose. You can use Kubernetes, whatever, locally. And it's just firing up these tests again and again. So I can say, okay, now check and verify this, and I can, depending on how fast my IDE reacts, very quickly verify, okay, this works, continue. Now, even nicer story here is I can here control verify the barista, that's what you've seen before, and I can run my coffee shop in a mode where it hot applies your changes immediately. So that is a feature of Quarkus. It runs in the development mode, and that actually works even with containers. So this is what I build up there. My container that runs is, where is it? Some temporary builder I put together for the coffee shop. So that is a container that runs Quarkus in a development mode. It is like a Maven compile Quarkus dev in a similar way like this. And what it does, it looks for changes under source main and source test, and will automatically apply them. So to show you this, I just did this, check the orders, or for example, see all of these hypermedia resources. I'm querying my application now, but also it has the connection to my code. So if I look into, let's look into this component, entity builder, that builds these hypermedia responses. And if I say, okay, go to this index page and change something here, hello world, then what it does, immediately it will apply that in my running application that runs locally, and I see the response right there. I don't have to restart. I know Quarkus is fast and Spring Boot is fast, but 5 seconds is too slow. I want to see it right now. And again, if I change this to, hello Lviv, something else, and I apply it, and there is my response. And again, I can just, in the same way, what I did before, where is it? I just started. I can again run my system test. In the same way, immediate response. Why? Well, everything is already running. My environment is right there. My database is still running, the barista mock, and I can just fire up the test again and get this feedback. So let me repeat that. What I can do here, I can build up an environment that I have to set up once. Can be Docker Compose, can be scripts. Actually, I don't care that much how I set it up once, and I can wait a few seconds once in the beginning when I take my coffee, and that's fine. But then while I'm in this mode of developing, I want immediate feedback. So whether I change something on the production code that changes my application, what I just saw with the hello world, or if I want to reapply my system test that ideally runs in idempotent way, that also should be done immediately. So I don't want to wait up for some startup for the system test each and every time. That should already be running and just tell me right away whether it's green or not. So for me, that's a very efficient way to test that locally. Again, it's not the same way that it would run in production here, because the development mode, you would obviously not run that, but it gives you a very, very similar experience, like 95% or more, where you get very fast feedback. And then for the rest of the pipeline, you're going to have another verification that I can show you in a second. So that is, for me, a very efficient setup that you can do for local black box system tests. Okay, now let's change the scope a little bit. This is now a system test similar to what I did on the command line in the very beginning. You can also have what I sometimes call smoke test. That is just an easier test that, for example, checks the health check and things like that. We can run this as well. That is located in my coffee shop project, so I can show you the project structure later. And that, again, runs very quickly because it literally just connects what is already running. But now, for a different scope, I also want to show you some code level tests. What I just showed you were system level black box tests using plain JUnit and then whatever Java technology you prefer. I was using JAX-RS for a client. But plain JUnit, why? It runs fast. So I'm in total control of my life cycle. JUnit itself does not start up anything for me. And where is my test here? I want to show you now some tests that where I have some code level tests and also some code level integration tests. So that is, again, a naive example. How I can basically do everything now on a code level without starting my application, but how I can verify my business logic. So the challenge we have with code level tests, and where is it? Yeah, that is an easy example. I didn't walk you through the code properly. So coffee shop is my business component, the beginning of my use cases and so on. So I would go to my coffee shop and that will then persist something. It has an order processor and then it does stuff. And then typically what we do in order to, unit test, let's say, this class, well, I need to mock all of the other components. I can do this, with Mockito. I can do this in a programmatic way. I can do this in a declarative way by running. In Spring, you would do Spring context tests. You can run something like a Killian or CDI unit. You can run something like Mockito extensions where it just add mock, injects your fields and then can mock something automatically, which is quite nice on the programmatic way. But then the issue we have with that is, well, a few things. So it's limited how you can build up your test cases, because sometimes you can only inject things right in your test class, in the single test class, but then you cannot delegate that easily. And most likely, if you use something like Spring context tests, per default, it will always try to fire up an application. for the life cycle of your test. So you start the test and then it tries to build up stuff, which is nice because that enables us to do add inject or add autowired for our components within the test, which is actually pretty cool. We can use a similar, known programming model, but it just makes the whole thing slower because then it needs to wait for that application context to start up. So for example, what I can show you, what I did here is a Quarkus smoke integration test, and I actually disabled it because, sorry, but it's too slow. Quarkus test is very similar like Spring context test, and actually it's a very performant technology, so it's very cool to, write these tests. But what it would do here, it would just, fire up Quarkus, which is pretty fast, but I have some database integration here and stuff like that, so it would just, take too long. Did I mention it takes too long? My flow is already gone. Normally, you're sitting here, but usually I would use my smartphone and, it takes too long. So even if we have some technology that starts up quickly, I want the same experience that I just did before, where just having immediate feedback. And for a code level test, the easiest way to achieve that is basically by having plain tests without any extension, without any JUnit 4 run with annotation, just plain JUnit. Now the problem, of course, is, if you would do this manually, like here, that is a naive approach. You have a lot of like this, right? I mean, it even looks horrible, right? You have a lot of programmatic setup of mock this, when this, then that, and nobody wants to write this. And it's not only cumbersome to write, the bigger problem with code level tests, and that's true in general, what happens if you refactor stuff? Well, and you can throw away the test class, or even worse, if you have a lot of test classes like this, you have to change and adapt all of them. But it doesn't have to be that way. What I want to show you is a notation that I was describing in my book also. I called it component tests there, but I think a better name is even use case tests. What I want to build up is code level tests that test the integration of multiple components of multiple classes, or basically the whole integration of a single use case, but only on the code level, without the integration of external systems, without the database. That comes later. And well, I want to write them in a way where they start up very quickly, where I can use plain JUnit, plain programmatic approach, plain Java, but I also don't want to write this. So what I'm doing here, I actually again use that code quality principle and abstraction by building reusable components and delegates, if you want, that are called test doubles, or TD, coffee shop test double, and or the processor test double, that double these production classes here, and that extend them, and that I can reuse in my tests. For example, I have my coffee shop, and then I build up something that I call use case test, and then I have my test double that resides within the test scope, which extends my coffee shop. And then why am I doing this? Well, I do this so that I can, mock and set up all the mock when verification logic only once. And of course, I then can extend this class with some, nicer, readable, business related methods. Something like verify, create order. Well, what does it mean, and then you have the low-level verification of this needs to be called and this should have been called and so on and so forth, that I then can use in a nicer way in my use case test. Same is true for the order processor test double that can set up, the capture, that verify can use this correctly. And now what's actually more interesting is this test, because that is the use case test that should test the invocation of the create order use case. And you see this is the test method. And this looks very clean because it just says create order. That's the actual method of my production code. And then verify create order, that resides actually in the test code. That gives me a nicer, readable API way to verify this logic. And you probably can guess it, this runs super fast because that's just plain JUnit, and plain JUnit is quick. It runs literally hundreds of tests in milliseconds. That once it has been initialized a few milliseconds, and then it's just super quick. And that is one way to build up your tests in a little bit more maintainable way, because now what we do, all of this mocking and wiring logic resides in these test doubles, And if something changes in my production code, if I make refactorings, well, then at least I don't have to change 100 of these classes. That is now only one class, but imagine, a more complex project. But I only have to change, like this verification logic here. So again, similar principle of just building these reusable components of making it a little bit more maintainable. So this is just, plain code level, but the nice benefit for me is I, again, get my fast verification. I don't have to wait for stuff each and every time. So plain JUnit, plain Mockito. I advise you to use S or J. These are very nice assertions that you can also build up yourself. And that's basically most what I do on in my projects for testing. So to give you a little bit better overview, let's build up some pipelines. First of all, focus on the upper half, local development. What I just did, step by step. What I typically have, one after another, is my project coffee testing, where that is my main project, coffee shop, where it would just build and test this project by Maven, run the unit tests. So that is the Maven phase for you can run Maven clean package. A lot of people would say clean is unneeded. You can run Maven package. You can run Maven verify, same outcome. And that will build your application, it would package it, and it would run the unit tests or surefire tests. What is a surefire test for Maven? That is every test that ends with test, T-E-S-T, like this. That will be executed, coffee shop use case test. What will not be executed is an integration test or IT. And that is a default convention. You don't have to configure everything. Just call your test IT and you will see it won't be executed. And that is a different phase that you can run than you would run failsafe integration test. You can run this either, I ran it before on the IDE or on your command line using this. And that is the second, or actually this bubble here. And that again runs very, very quickly. Well, here I have to wait for Maven startup, but in general, you saw it in the IDE that can run very fast. I already show you that. In the middle, deploy locally, ideally in a mode where I can just hot swap my application very quickly. This was basically what I showed you here. In this case, I have 3 Docker containers, one with this connection to the development mode in Quarkus, which is quite nice. In general, just actually, I don't care that much how you start it up. Can be quite, a little bit hacky or using bash scripts. Actually, for me, it's fine if that means I only have to wait once. I know a lot of developers are fans of, Java APIs that you can use programmatically or in the declarative approach, like test containers. We had a nice talk about that. And I get it. It's, nice to write it in Java. But in my eyes, it should at least allow you to separate these life cycles. That you don't, and I claim that might be a limitation of JUnit, that you don't have to do everything or whatever you're trying to do in each and every test run. Because typically that's connected with the test extension or annotation that you put there. And then for each and every test run, it tries to do something. And if you want to break out of this, then you always have to do something like a workaround, right? For example, if you say I have a container and should be reusable, then I can check if it's already running. But for me, I would say, okay, wait a second, I don't want to tangle these life cycles all together. I just want to start it individually and then keep it running and then run my test that already assumes that something is running here. So my smoke test assumes that this step was there before. And I can, just make this sure and then have a single command. I use bash scripts with Docker run because quite honestly, for me, it's still the simplest way to do that. But I get it. A lot of people try to abstract that further. That's fine. Then you can start up something else. However you want to start it up. For me, it's important you start it up once, where you wait for a bunch of seconds, but only once, not each and every time. So don't, restart stuff. Sometimes you have to, yes, but while you're in this mode of, writing something and feedback loop, that should be fast. So whatever technology you use. That's actually very similar whether you use Spring, Quarkus, Java EE, or something like that. It's more about the approach here. So now these ITs are part of my coffee shop project, same project that I showed you before. So that can be, a very simple smoke test. The smoke test means just check whether the whole thing even came up or whether it just, blew up immediately, right? For example, if you have some wrongly configured annotations, whether Spring or Quarkus just complains that you did a mistake, then this is a very quick way to, to notify, to check this and see this, to notice this. And then system tests, these in my case reside in a different project that has reasons for, well, basically manageability, because sometimes what can happen if you manage all of the tests in the same project, then it's very tempting to just reuse classes that are already there. And we have seen false negative by just not detecting changes that you've made in the API. For example, if you change some mapping classes in Java, and if you use the test in the same project, well, it uses the same changes and change matches, and then it's green, although you just, for example, change the external API of your application, right? If I would change the JSON mapping to the outside, for example. So I say it's quite simple to just separate that into a separate project. And in my case, for example, I can show you the order of my system test. It looks much simpler. It's kind of a dumbed down version of my order, but that's fine. I can use only strings for system test. That's fine. And then, fire that up in my coffee order system delegate here and users here. So it can be, separated in that way. Put this test here. That's fine. And you saw that. I can just then run my system test that I did before. I can Maven verify that is still running. I can run this also in the command line. Maven verify, because these are all tests, surefire tests in my case. And then it runs these tests. One takes a little bit longer, and that's fine as well. So then what you would do in a CI/CD pipeline, second half, is very, very similar. But now we get another advantage of separating the life cycles, because now I can run my same tests even against a properly deployed environment. For example, I can build up the same thing, what I just saw before, whatever. And then I can say, okay, hold on. In this environment, I now want a more proper staging system test environment that actually deploys to Kubernetes. So assuming I have some Kubernetes cluster. Oh, and by the way, I have a Kubernetes cluster. Kubectl get services, or kubectl get nodes. Actually, here from, I use mostly IBM managed Kubernetes cluster on the cloud. You can also use, a local Minikube on your laptop. You can use any other cloud. You can have a managed installation, whatever. I use this, and in this case, well, I want to apply, assuming I'm now the CI/CD server, coffee shop deployment system test. I want to apply some resources, bam, and I now fire up the same system test environment, system test, because I actually use the mock server. That works there as well. I can swap that in Kubernetes deployment. Nice extra benefit of Kubernetes here. And, well, then I can run the same tests against Kubernetes, actually. Because if you paid attention, my code just says, by the way, it just connects against the system. And if I want to reconfigure it, I just set a property differently that is not localhost but something else, but everything else is the same. Everything else is similar. So in this case, I can say, well, you know what? Instead of using, I can show you a magic script that gives me the IP address of my cluster and says, oh, by the way, this has been deployed. Great. It's up and running. And now I can fire up, my system test or my smoke test. Verify. No, that's not verify. That's integration test. By just pointing these variables to my cluster, and then it will actually fire my test against the cluster. And again, I reuse the same test scenarios that I wrote before. So that works. And the same is true if I want to run my system tests. Verify. I just set all of these variables again to the different components, and then I just fire up that against my cluster, or the CI/CD server would do that. So I have reusable components that I can use with other test drivers, that I can use as part of other test scenarios, and I don't have to rewrite my code and duplicate a lot here all over again. So for me, that's just the advantage. And if I now go and curl for the orders here, I see that this actually also happened, that there was something happening in my cloud. So that fired really against my cloud. And that just works here as well. So it just points to a different environment, and then from there it goes on and goes on. You can say, okay, now I want some performance tests that reuses, similar components and just fires that up very quickly. Or in this case, actually that's an Istio cluster. I want some Istio capabilities to test the resiliency, and I want to introduce some errors and then fire up the same system test and see how my application behaves and things like this. Then you can build upon that by just having these reusable building blocks. So in this case, these are just important principles that I advise to follow. And in my eyes, that's a technology that makes it very simple to mostly care about these principles and constraints that you do before you introduce a lot of extra test technology. So that is just abstraction that should come on top of it, but mostly your test technology should allow you to build reusable components and abstractions, and not all of them do. So for example, to delegate like I did here, and it should allow you to separate life cycles from tests and test environments. To say, I fired it up once, whether it's locally, whether it's on Kubernetes or somewhere, and my test should not, tangle with this lifecycle because it might assume that it's already running, because it might not even, have the connection to Kubernetes or something like that. So then it just connects, and in my eyes, that's just easier to manage by keeping that separate. And a few takeaways for you. So usually, actually, I would read that list to you, but you can read yourself. But that's just an important matter that I see in projects, but also I was talking about this topic a lot, and not always it helps. So this time, for the first conference, actually, I want to do something different. So instead of reading these key takeaways, I actually wrote you a poem for testing. Maybe that will help. Tests that spark flow by Sebastian Daschner. Are you struggling with tests? Are they unwieldy and slow? Do you fear code changes and you just can't stay in the flow? You need to be flexible and efficient. Your tests need to adapt to a fast-moving world where quality is not an issue, and to deploy to production, the place where we are supposed to be. Verify the app's behavior as well as the integration, you see? What you need is fast test feedback, and you'll be fine. Plain JUnit is quick, runs hundreds of cases in no time. Don't fall for seductive test frameworks. Rather care that your test code quality is right there. Build up abstractions, reusable components, go delegate. Otherwise, an unmanageable test code will be your fate. Separate those life cycles of tests and test environments. It gives you a short turnaround as you develop locally, my friend. With that, enterprise testing can be a joy. There is no need to cry. Now go home, improve your tests, and thank you. Goodbye.